In this video, I'm going to cover several of the basics of working with matrices. In this first slide, I really need to talk about some vocabulary. And so, pause the video, write these things down. These may be things you've already seen before if you've had a basic intro to matrices, but in case you haven't, here you go. So, first vocabulary term, element. The word element just refers to any single entry in a matrix. It may be a number, it may be a variable. So, for instance, if you've got, 1, 2, A, 5, the elements here are 1, 2, A, and 5. So if you ever see a question asking you to find a particular element, it just means find, a particular number or a particular entry in a matrix. Okay. The rows of a matrix are the horizontal lines of numbers. So the rows in this matrix up here would be 1, 2, or A and 5. Right. So there's the first row and there's the second row. Not a big deal. Next up are columns. Right, columns are the vertical lines of numbers in a matrix. So this has columns of 1A and 2, 5. So rows are horizontal, columns are vertical. Yay. The last basic thing is the dimension of a matrix. The dimension of a matrix is always given as some number times some other number, or some number by some other number. And that first number always gives the number of rows, and the second number always gives the number of columns. Okay, so for instance, the matrix I have up above is a 2 by 2 matrix because it had 2 rows, the red ones, and 2 columns, the blue ones. If I drew a matrix like this, 1, 2, 3, A, 5, B plus 1, what would the dimension of that matrix be? Well, we counted out. How many rows does it have? It has 1, 2, 3 rows. So this is 3 by. And how many columns does it have? It has 1, 2 columns. So 3 by 2. That's a 3 by 2 matrix. Truth be told, the vast majority of the work that you're going to do is going to be with square matrices, which means 2 by 2 matrices and sometimes 3 by 3 matrices. Every once in a while you'll deal with one that has a different number of rows and columns, but the majority of our work is going to be with square matrices. So the next thing I want to talk about is the first matrix operation. There are several matrix operations, and the first one that we're talking about is this idea of scalar multiplication. And I've got a note there. I'll come back to that note in a minute. Scalar multiplication means what happens if somebody has a number that's outside of a matrix, like 2A, B, -4. And what happens when you have just a number, and it's called a scalar that's right outside of a matrix. And the note I have here is that the scalar multiple has to be distributed to every element inside the matrix, not just a single row. It seems like the most common misconception is that you distribute the 5 to the top row, or maybe to the bottom row. And the reality is that you need to distribute it everywhere. Right? So if I distribute that 5 into every element, I'll end up with 10, 5A, 5B, and -20. Okay? In case you want to try one of those on your own, suppose that you had this. 1B plus 1, 3A squared. So pause the video for 10 seconds, write that one down, and then play again to make sure you've got it. Again, really not a big deal. You're just kind of distributing in. This is -3, -3b minus 3, -9, and -3a squared. And I hope you notice that I'm trying to get you used to this idea that it's not scary when you see variables inside. It's not even scary when you see a b plus 1. You're just like, whatever, when I distribute the -3 to that, I will distribute it through and end up with that. Okay, so scalar multiplication, not a big deal. You just take the number, or, actually, this could have been a variable out here. Take that thing and just distribute it into everything that's inside. Okay? The next matrix operation is addition and subtraction. The note that I'll give you here is that two matrices can only be added or subtracted if they have exactly the same dimension. So if someone were to ask you to do 2, -1, 4, 5, plus 1, 2, 3, 4B, that was supposed to be a 5, but that's okay, 4B, 5, this is not possible. I suppose I would say that this is undefined. No one's going to ask if it's undefined. All you're going to say is that this is not possible. The reason it's not possible is that this matrix here is 2 by 3. I'm sorry, 2 by 2. I'm having a good time this morning. 2 by 2. And this other matrix is 2 rows by 3 columns, so it's 2 by 3. Because these dimensions are not the same, we can't do this. Right? But if they are the same, then matrix addition and subtraction is so incredibly easy. Right? It just means you take whatever matrix you have, 1, 2, 3, 4, plus b minus 1a 4b, and you simply add them together element for element, right? So you'll do 1 plus b minus 1, that'll give you b. Then you can do 2 plus a, alright, that is a plus 2. We could have done 2 plus a, but I wanted to put it in that order. Then we can do 3 plus 4, will give you 7. And finally 4 plus b, I'm going to write as b plus 4. Okay? Not a big deal. Matrix addition and subtraction is simply a matter of adding together the corresponding pieces and subtracting the corresponding pieces. If you feel like you need an example of that, I'll give one below. If not, you can skip over it. So let's see here again. I'm going to do a 2 by 2. We could do a 3 by 3, but for the sake of moving the video along, I'll do 2 by 2. Let's see here. If I do a 5 negative 3 b plus 2 minus, let's see here, 3 7 2 and I don't know, b squared. Take a minute and write down what that is, what that subtraction will end up being. So you should have here that you've got a minus 3, so a minus 3. You've got 5 minus 7, that's negative 2. You've got negative 3 minus 2, that's negative 5. And then finally you've got b plus 2 minus b squared, so literally b plus 2 minus b squared. And I'll say again, a lot of people worry when they're like, oh no, can you really do this? Like, is that really just one element? It is. This matrix has 4 elements in it. I'll admit 2 of them are really simple, and 1 is a lot more complicated. Not a big deal. My next property is equality, and this is a really basic property. The way the problems get a little bit more complicated is when you try to put it all together. The concept of equality is simply that two matrices are equal only if every single one of their corresponding elements is equal. And that makes sense. Like, I mean, you know, if I asked you, I'll scroll sideways here for a second. If I were to ask you, you know, is the matrix 1, 2, 3, 4 equal to the matrix 1, 2, 3, 5? You'd say, well, no, because they're not exactly the same. So the key is, if the things are exactly the same, then they're equal, right? So coming back over here, my example question asks, find the values of the numbers a and b if these two matrices are equal to one another. Right? So what it means is we kind of just set each of the 4 pieces equal to one another. We say, okay, 4 is equal to a squared, a plus b is equal to 3. I would write down negative 1 is equal to negative 1, but it doesn't seem very useful, so I'm going to skip that one. And then the last one, 3 is equal to b minus 2. And so now I have the task of solving for a and b, right? So if I take this one over here on the far right, notice I have 3 equations with 2 unknowns. I can probably get rid of one of these equations, but I'm going to kind of use them to check things. In the far right equation, if I add 2 to both sides, I'll end up finding that b is 5. Great, so b is 5 now, right? If I go over here to the far left, if I square root both sides, I'll find that a is plus or minus 2. So you're like, okay, it's plus or minus 2. I do have this third equation though, so I should look at what happens here. If I plug b being 5 into this, I'll end up finding a plus 5 equals 3, which means a has to be negative 2. And so what we find is, and you have to be careful here, you need to take the most stringent of all of these numbers. So over here where I had that a was plus or minus 2, that's great. That works for the first element. But a being, great, so we find that a is negative 2. A being positive 2 is going to change the value of b, which means it wouldn't have worked over here. So the only answer we get for this problem is this one, that a is negative 2 and b is 5. Okay. I have one last example in this whole video, and it's one I'd really like for you to do on your own, so we'll go look at that next. So find the values of the real numbers a and b such that a minus 2b equals c, and here are these matrices. This is a fairly common question on the AP exam. This is something that they like to ask. What it means is you basically need to do this. You need to write down a, and then minus 2b, and then equals c, and work those things out. So I'd say pause the video and at least write down a minus 2b equals c, and do what you can to simplify that. Right? So you're going to have 5a, 3a, negative 3. Again, I hope that you've paused and done this on your own. Minus 2, 2, negative 5, 1 minus b, negative 3, equals 1b, 13, 3. Great. So if you have that yet, you know how to set it up. The next step is, how do we simplify this thing, right? Depending on your mathematical ability, you may be able to do this all in one step, or you may do it in fewer steps, but think about how you could simplify this stuff on the left. And I would say even pause the video for 3 seconds and answer what could you do over there first. Hopefully what you said was that you could take the negative 2 and distribute it to all of these things. Right? So my first matrix is going to stay intact, 5a, 3a, negative 3. And then I'm going to put plus, because I'm distributing a negative 2. Negative 4, positive 10. This will be negative 2 plus 2b, positive 6. And I didn't do anything to write yet, so I'll leave this alone. 1b, 13, 3. Okay. So next, what's the next thing you could do to simplify this thing? Well, hopefully you recognize we could add together the two matrices on the left. So when I add together those two matrices on the left, I get 1a plus 10, 3a plus 2b minus 2, and positive 3. And all of that is supposed to be equal to 1b, 13, 3. And so what I hope you notice is that I walked you through this entire lesson. The first thing I showed you was how to do scalar multiples. The next thing I showed you is how to add matrices together. And the last thing we covered in this video today was, if you have two matrices that are equal to one another, what can you do? Hopefully you either said out loud to your computer screen, or you were thinking in your head that you can set corresponding parts equal to one another. So that means that 1 will be equal to 1. Okay, cool, nobody cares. 3 will be equal to 3. I don't care about that either. Then we get to the important ones. A plus 10 has to equal b. And then the other important one, that 3a plus 2b minus 2 has to equal 13. 3a plus 2b minus 2 has to equal 13. And this should look really familiar. This is a system of equations. I can take this thing and I can solve it using elimination or substitution, whatever method you like using. So again, for practice with that Algebra 1 concept, pause, do this, make sure you can do it on your own. I've got 3a plus 2b equals 15. Then, because this is already set up so nicely, I'm going to do substitution. I'm going to move this over and plug it in for b. This will give me 3a plus 2 times a plus 10 equals 15. 3a plus 2a plus 20 equals 15. So 5a equals negative 5. So a is negative 1. When I take that and plug it back in, negative 1 plus 10 is b. So b is 9. That's the end of this video. There are more operations coming up. In particular, we need to talk about multiplication at some point. There's lots more to do, but that's all for this video. I'll see you in the next one.